It's good to see you streaming a bit, FizzBuzz. Okay, YouTube's up. All right. Greatest achievement of your life. Yeah. You should call your mom and tell her that you got first. Um, this linear algebra question I brought up at the end of last stream, I didn't get a chance to answer it. I'm debating if I just want to do physics today or what, though. Can I answer this one question and then do physics? I don't know why I'm asking that as a question. But let's see if I can figure this one out. And I'll probably do some mechanics studying. If lambda equals 0, x is in the null space. Yes. If lambda isn't 0, x is in the column space. Yeah. Yeah. So like I meant to put a thing in my Discord saying that. Starting this Saturday, the first 2 hours of each my Saturday, I will say Shatterday. Shatterday is every morning for me. You know what, we can do that on stream. Why not? Um, so let's write a Discord announcement on stream. That's a great. People love watching that, right? And general announcements. Related to the reading group on general relativity starting on Saturday. 2 days. That's two days. Okay, yeah, 2 days away. The first 2 hours of my Saturday streams, I will not. No, caps not is too aggressive, right? I will not. Let's do italics. I mean, the first 2 hours of my Saturday streams will not be math help streams. Math help streams. Hey, Rapture. Streams. Oh no. God damn it, Central. I know you're messaging me something stupid. Hey, Kevin. I have to check though. I can't handle having pending messages. Yeah. Just get on with it. Holy shit. I knew it would be something stupid. Doing Calc 2? Oh, nice. Let me know if you have any questions, Kevin. Yeah. It's gonna happen every time. I'm gonna write this first and then I'll check it. It's gonna be something even more stupid, I'm sure. You have a lot? Feel free to put it in chat, or you can join my Discord that I happen to be writing an announcement in. Didn't do on the first exam? Oh no. There's some weird stuff that you have to learn in Calc 2. A lot of students find that it's the hardest one out of the kind of 3 semesters that a lot of students have to do. No, this is a dumb way of phrasing it. I hate this, dude. I hate having notifications. People have like 10,000 unread emails or a million little pings here. I don't know how they do it. I can't handle it. My Saturday streams will have a different schedule. The first 2 hours will not be math help. They will be dedicated to the reading group. Then after / around the 2 hour mark, I'll do math help for another hour or two. Is that all I need to say? I think that's all I need to say. You have over 1,000 Discord unread pings. Just put them on mute. Like, I don't know, dude. Every time I join a server, I put it on mute. The only server I don't have muted is my own. And for most servers, I suppress the @ever and @here. The best thing to do is to go to math homework help and make a new post. If that's giving you issues though, just put it in math discussion. I think that's everything I need to say, right? Okay. Bam. Discord announcement written. What stupid shit did you message me, Central? Oh my god, that's disgusting. It says 1K. Unbelievable. You want me to show the people this? All right. 1K. Imagine having that many Discord pings. Disgusting. Hey, Scorpra. Okay, Kevin. I see you put hi in math discussion. I don't see a thread in math homework help, though. Sequence in the series? Okay, I can definitely help with that. Did you hit post on your thread? Hey, Slim. Posting. Oh, okay, cool. Question on screen is pretty good. It's interesting that it leads to eigenspaces in joint canonical forms. Choose that character polynomials don't need to split over the reals. When they split over the complex numbers, a good easy example is the rotation matrix. Right, yeah, I've seen that. Yeah, unfortunately, I'm gonna have to keep people in suspense for my insights or lack thereof, because Kevin's about to post a calculus question, but I was planning to do this one until I got distracted. By the way, check out Academy of These Ideas, aka Slim. Cool streamer over there. Fellow math streamer. Hey, Jasu. Okay, once you post it, Kevin, just give me a heads up in chat. In the meantime, I'm gonna think about this linear algebra question. So okay. Those spaces have dimensions n minus r plus r equals n. But I remember this, when I was reading the statement at the end of the last stream, I was kind of weirded out by it. I think the book, these big ideas you really need to know. I mean, the entire kind of theme, at least as I understand it, for Academy of Use Ideas, is that it's about like appreciating math just for the aesthetics of it, rather than some application of it, which is kind of the opposite of why I like math. But I think the world needs like both types of people. I mean, apparently, I really need to know those 50 big ideas. I think you could quite easily disprove this with a counter example. Really. Oh, I okay, maybe I see what they're saying now, where n minus r is the dimension of the null space, r is the dimension of the column space. Um, why doesn't every square matrix have n linearly independent eigenvectors? And so yeah, this isn't supposed to be, or like, we're supposed to be saying why this thing isn't true. And I'm still trying to piece together what exactly it's saying, I guess. Um, and I'm assuming like lambda x isn't the entire column space, it's just a part of it. It's just the columns that don't change direction after applying a transformation A to them. Which, how do the maybe I need to look back, like how does this book explain eigenvalues without explaining what a linear transformation is? I think it kind of explains it in linear transformation terms without while avoiding the bigger idea. Which feels kind of weird. Um why doesn't every square matrix have n linearly independent eigenvectors? I mean, is it as simple as like a minus lambda I has a different column space than A? Like these are two different matrices? A store? I don't think I've had anyone call me a senorita before, but you know, I don't care. I'm just thinking about question 26 here. We're potentially going to get a sequences in series question from Kevin. I haven't seen it posted yet, though. Oh, maybe it just got posted. Okay, yeah. That's good timing, right as I was having to check the Discord. Easy mathematical ideas you really need to know in philosophy. Ooh, neat. Central, I hate you. Ugh. Okay. Determine whether each of the following sequences is convergent or divergent. If the sequence converges, find its limit. If it sequence diverges, explain why. Okay. So for number 7, sequences are a lot nicer than series because for sequences, the test is pretty much always just do the limit, and the limit as n goes to infinity, and this is just a normal like calc 1 limit. Zoom. Oh yeah, I can zoom it. It is a little faint. Especially if you're on mobile. I hope that's better, Storm. You don't know? Okay. As you DM me again, let's see. You're the worst. You can zoom on mobile? Oh, I didn't even know that. Okay, so if you just have the sequence like we do in part 7, you can just always do limit as n goes to infinity, and from there you can do normal calc 1 rules like L'Hopital's or what have you. And asking if a sequence converges or diverges is the exact same as asking if a limit converges or diverges. Here we have an exponential. Wait, do we Storm? I don't think so. That's for a series. That's like the ratio test. Oh, or you... I'm pretty sure it's just the limit, isn't it? No, yeah, I think you just take the limit. Yeah, you do. Okay. To evaluate this limit, I think you could probably do L'Hopital's and get somewhere with this. Hey, G, maybe can we say that n squared is n times n? What would we do with that though? Yeah, I think we. Well, you need L'Hopital sometimes, Storm. I'm looking for exponent tricks we can do first. We uh we can say that this is the same thing as e to the 2n times e cubed over e to the n squared. And we can do actually, I don't think we even need to do that. These two numbers have the same base, if we have 2n e to the 2n plus 3 and we're dividing e to the n squared, I think we can just subtract the exponents and say it's the same thing as e to the 2n plus 3 minus n squared. For the same reason that 4 to the 4th over 4 squared is, oh, that's bad. Let's say 4 to the 1 is equal to 3. That 3 is just 4 minus 1. And so we're doing the exact same rule here, just that we have some weird ends instead. Sorry for the motorcycle. You can compute every limit without levels. You're expected to use it in some calc classes, though. And so the point of doing this is that, I mean, you could think about something in a few different ways. I think what I'm gonna do is say this is the same thing as e to the, like, all the ends are just in the exponent now, so we can bring this limit into the exponent also. And this is a parabola that opens downward. It's just going to shoot out to negative infinity. And so e to the negative infinity is like 0. Or it approaches 0. Because e to the x looks like this. And if you go out to negative infinity, you're on this part of the graph as you get close to 0. So that's how I think about part A. For part B, this one's going to be a lot shorter. Sine, as n goes to infinity, it doesn't converge to anything. It just oscillates up and down forever. I would say this limit just doesn't exist. You can't pin it down to just one value. So I'll say DNE for does not exist. DNE sine n pi over 2 oscillates is the reason why. Well, that's getting into like epsilon stuff, isn't it, Storm? Like, or epsilon n stuff. I think for Calc 2 class, this is normally good enough. Well, okay, we could be more specific with how it's oscillating. Like, you're right, you can have a function, like, you could stick in e to the minus n in front of that, and you would be fine. You probably don't need anything like that fancy either, but I think you're going a bit too far with it for at least the purpose of this thing. Oh yeah, Mert, that's fair. I like that more than going to like epsilon n. Mert is suggesting that we can build two subsequences that go to different values, and that will be a way to show that it doesn't exist. So, okay, fine. We can do that. So that's not so bad. So the value of this limit is going to change depending on whether you have an even or an odd n, which is what Storm is suggesting here. So if we looked at just the evens, Maybe I'll use a different letter K. And we should say the limit as k goes to infinity, a sub 2k. That's going to be the same as sine of k times pi. And that's always 0, right? Whereas the limit as k goes to infinity, well, odd numbers is 1 or minus 1. To make it cleaner, we should maybe I'm gonna say if I want it to always be like pi over 2, maybe I'm gonna say 4k plus 1. And this looks weird, but the point of it is that if k equals 0, we have just pi over 2. When k equals 1, we have 5 pi over 2, which is just pi over 2 plus 2 pi. So on the unit circle, it's the exact same thing. And that's the behavior that I want. For k plus 1 pi over 2. This is always equal to positive 1. I'm doing this weird thing because I didn't want it to... If I made it just 2k plus 1, then sometimes pi it will be positive 1 and sometimes it'll be negative 1, and I wanted to avoid that. I just wanted it to always be the same thing to cleanly show that with one subsequence we can get 0, with another subsequence we can get 1, so that it has no chance at converging. If a sequence converges, then every subsequence must have the same limit. So if you name two subsequences that don't have the same limit, then it must diverge. I see someone else posted a question in the Discord after this. I'm not sure if I can do it, but I can take a look at it. I don't know very much about Latin squares. Use an appropriate test to determine the convergence. Absolute or conditional. Ugh. French mathematicians get upset at hand wavy. Storm does like to be rigorous, I've noticed. Okay, so the first one, I would say to use the alternating series test. I didn't mean to do that. French like to do true math. And how you set the alternating series test is you do the limit as n goes to infinity of the absolute value of the series. It's a relatively simple one to apply. Alternating series are more likely to converge because they have cancellations. All the absolute value does is basically let us chop off that -1 part. And that's great. So it's just limit as n goes to infinity of 1 over 2n plus 5, and this goes to 0. So because it goes to 0 and is decreasing, we can say it definitely, this series converges, but we have not determined a conditional or absolute yet. If we want to figure out conditional or absolute, we need to look at the series without the -1. Like this. And this is just a different version of the harmonic series, 1 over n. Like, you can slam a 2 in front of it and it doesn't matter. You can plus 5 and it doesn't matter. it's still basically just the harmonic series. So I expect this thing to diverge. We can show that a little more formally using the limit comparison test. Which is limit as n goes to infinity of the series that you started with, divided by any other series that you know how it behaves, and I'm going to say 1 over n. So I'm going to unflip these fractions to be n over 2n plus 5. And because the degree on top is 1, the degree on bottom is 1, this thing is 1/2. You do the leading coefficient divided by the leading coefficient. And so because this is equal to a finite number that's not 0, these two sequences behave, or these two series behave in the same way. And 1 over n diverges, so it must be that 1 over 2n plus 5 also diverges. So the alternating version converges, the absolute value diverges. That means conditional. Sorry, I should write over here, diverges. Conditionally converges. That's like the overall conclusion we would draw here. For B, Storm had a suggestion for this one, right? Oh. Yeah. That's fair. Is there a different way we can do this arctan? Actually, even then, I'm not sure how that identity necessarily helps. Yeah. Arctan 1 over n, I think it looks as a graph like that. Luis Santos. Oh, are you the person who posted about the Latin squares? Yeah, I'm willing to give it a look. I'm gonna have to Google what Latin squares are though. So that's why I'm not completely sure if I can help with that one. But okay, I'm gonna like arctan is a weird series to work with. I think I want to try limit comparison here. And I know the derivative of arctan is relatively nice. And so I want to use L'Hopitals if I can. So I'm just gonna, I know that if you have just arctan x and you take the derivative, it's like 1 over 1 plus x squared. So I'm just gonna try comparing it with 1 over 1 plus n squared, and let's just see what happens. 1 over 1 plus n squared is a piece, like, you can say this thing converges because it's like a p-series. If n goes to infinity, that 1 over n goes to 0. Arctan of 0 is 0. This thing on the bottom goes to 0. So we do have indeterminate form, 0 on top, 0 on bottom. L'Hopitals is allowed. Arctan is going to become 1 over n squared plus... Oh, wait. It's... I need to verify this derivative. For whatever reason, I'm tripping out with this. It should be 1 over... It should be like that. times chain rule minus 1 over n squared. Well, that's funny. Okay. I want to verify that derivative though. For reason I'm getting tripped up on the chain rule there, or how exactly it should be like how I wrote it. Okay, yeah, I got it right. I just plugged in Wolfram Alpha quickly in the background. Limit as n goes to infinity. So I'm gonna do this fraction math, or I'm gonna do this math on top first. The n squared will get multiplied into the bottom, like it'll get distributed. 1 over 1 plus n squared over 1 over 1 plus n squared, and that just comes out to be constant -1. So I think this thing converges. Let me just make sure for limit comparison. Does it need to be positive? We could make it positive. No, yeah, I think we're okay. Oh wait, oh, C has to be positive and finite. Oh damn, I don't think my comparison test actually works. Oh wait, I didn't do the L'Hopital's right. I didn't take the derivative of the bottom. Minus 1 over 1 plus n squared, parentheses squared, times 2n. That's the proper thing. I see you asked what, can I explain the chain rule? Let me get through this problem first, though. That's kind of a separate question. Or let me get through at least like this piece here first. Oh, now this comes out to be... Oh, this doesn't converge now, does it? Okay, so I'm getting 1 over 2n, and that's going to be equal to 0. So this thing isn't a good comparison. You don't want to get 0 for your limit. So I'm going to try Storm's suggestion here that it's similar to 1 over n. L'Hopital should still apply. I shouldn't have erased that last part. I should only have erased that part. Minus 1 over n squared. This should work now. Limit as n goes to infinity. These 1 over n squareds with minus signs cancel. So we get just 1 over n squared plus 1. And so as n goes to infinity, this piece goes to 0, so we just get 1. So now these things behave the same way, and we know 1 over n diverges. So that series is going to diverge. Arctan 1 over n. And so you're asking to explain the chain rule? I was getting tripped up on taking the derivative. I assume you're maybe similarly confused on the derivative of this. And so to do this chain rule, I start by remembering, like, forget about the inside, but pretend it's just n or x. If you had just arctan of n, we'd have 1 over 1 plus n squared. So now when we have arctan of something weird, that's not just n, it's going to have the same form, 1 over 1 plus, but now instead of n, we have whatever's inside parentheses, 1 over n squared. And now, because of the chain rule, we have to take the derivative of the inside and multiply it in. So the derivative of 1 over n is minus 1 over n squared. And that's how the chain rule works there. Part C, when I see a series like this, I just have seen these before, and I know they are normally the integral test. We have an ln n and a 1 over n, so it's going to be a relatively easy u sub here. So let's try the integral test on that one. I haven't heard of Bertrand criteria before. Is it related to integration? Yeah, okay. That's probably just the same thing by a different name. I think actually for the integral test, we normally switch it to be x. It doesn't actually matter, it's just a letter. Now we just have a normal integral to do, and if the integral converges, so does the series. If it diverges, then so does the series. Would I either gain muscle or eagers? I don't know what that means to fructose. I would do a u sub here, u equals ln x, because du will be 1 over x dx, and look at that, we have a 1 over x dx right there. So the integral will just be 1 over u to the 3 over 2 du. And I'm just going to drop the bounds for now and bring them back later. 1 over u to the 3 over 2, just to really draw this out, is the same thing as u to the minus 3 over 2. And we can do a power rule with that. So you add 1 to the exponent, so we'll get negative a half, and then you divide by that exponent. So dividing by negative 1/2 is like multiplying by negative 2, u to the minus 1/2. And now I'm going to unsub minus 2 ln x to the minus a half, and I'll bring the bounds back from 2 to infinity. 2 limit as t approaches infinity of 1 over root ln of t. That's what I get. Like, instead of doing, I don't want to literally put this infinity inside of the ln, so I'm making it a limit instead. Minus 1 over root ln of 2. And this exponent of negative 1/2 is the same thing as doing like 1 over root. Dumbfeed, thank you for the follow. This piece here is going to go to 0 because ln of infinity goes to infinity, so 1 over infinity is going to be 0. Hey, Dumbfeed. Root ln 2. Okay, so the only thing that really matters here is that I don't care what this number is, but it is just a number. This integral converges to something. And so because the integral converges, the series must also converge. So I hope that helps, Kevin. Let me know if you have any questions about that. Give an example of orthogonal Latin squares using the honor cards from a standard deck of playing cards. I need to A, remember what a Latin square is. B, remember what an orthogonal Latin square is. uh, the image is kind of weird. There's only so much I can really zoom on this. I have the same question, gamer. I've heard of them, but I don't remember them. Actually, you know what? I can take a screenshot of this and bring it back into the thing. Latin square cuisine? Really? That's weird. Okay. Okay, so it's just you can only use the same thing once in each row and column. Now, what is an orthogonal Latin square? Interesting. Okay. And so these are orthogonal because if you look at the upper left-hand entries, you get 1, 1. And you can also get 1, 3 from the middle entries and 1, 2 from the bottom right. You can get every combination of 2 from 2, 2, from 2, 1, and from 2, 3. And then same thing with 3. That cat emote is really cute. Oh, so they just really what they're asking is for is a 4x4 orthogonal Latin squares, and this is just the answer here. uh, like we could assign 1 to Jack, 2 to Queen, 3 to King, 4 to Ace. So you use matrix and make a product between A and the transpose of A. Oh, maybe. Wait, didn't we already say mutually orthogonal? I know, just orthogonal. I mean, we only need orthogonal, but what is mutually orthogonal? I don't know what that means. No. Okay. Let's actually construct this, so let's not just cheat. I'm going to say ace is A, king is K, queen is Q, J is Jack. So let's just start by making one Latin square. A, K, Q, J, K, Q, J, Q, J, K, I guess. And then we need to have an ace here and here. We can't. Ooh. I need to put Jack here, so I can put Queen here, which means Queen. Oh, but Queen can't go there, so I put King there. And wait, what? Never mind. Oh, I guess I could just. Is that the more systematic way of doing this? Just think of it as like a sliding it down. Oh, this seems to be working. A K Q. There we go. Basically, what I did, I just made that first row in arbitrary order, and then I kind of slid everything down one, and whatever's on the left came back around. And so now if we want to be orthogonal, can we slide it the other way? Is that what we do? Let's just try that and see what happens. Start with the same first row. So we slid it the other way. The Jack would come here. A, K, Q. Then the Queen would come here. J, A, K. And then slide it again. Is this a Latin square? Let's check all our rows and columns. Yeah, it's a Latin square. Okay, so we can get our like ace pair, or we can get all of our like pairs of two of the same things from the first row with the first row. And then let's check it through for like ace comma something. So we have this ace comma queen. We have ace. Oh no. That's not what we want. I just repeated ace and ace. That means I'm going to miss out on something. Yeah, Jed. You're right. These two rows are the exact same. Or like I wanted the first two rows to be the same. I didn't think about how that would make the third rows the same though. Um could we like if we swapped these two rows, I don't think that's going to be it. Like we need something stronger to break the symmetry, right? Storm says we could swap rows 1 and 3? Really? Let's try it, I guess. Jed says no. I feel like that wouldn't do it either. You have 2 queen ace pairs? Okay. Um, make the second row pair A on the left with king on the right. Oh, maybe that's a better way of thinking about it. If the first 2 rows give us all the same pairings, then let's work on this ace pairing with a king. Let's make sure this ace, it should have to pair with a jack because we have a queen up here. This ace would have to then pair with a queen. Okay, yeah, I like this. This is a much better approach, I think. Then let's think about kings. We have the king-king pair. We want this king... king ace, we already... no, we have ace king, but king ace is different. We can't put an ace here, though. Oh yeah, you're right, Jed. We can just fill these in. We have enough information. Because we can't have a king... The only thing that go here is king or ace, but we can't have a king because of that king. So let's put an ace there, king there. This has to be a jack, right? Because this says we need an ace or a jack. That says we need a queen or a jack. So then a queen has to go here, and ace has to go here. This spot here, this says king or jack. This says king or queen. So king there, jack here, queen here, ace here. All right, let's check this. We engineered it so the aces work. I don't think we need to check aces. Kings. King, king. King, queen. King, king. No, not good. That's so weird, though. Hey, Kryn. First time on YouTube. Welcome to the YouTube side. Now do it for a set of 100 elements. I can't do it for a set of 4 elements, apparently. That's so weird. How did that... I thought that was a good approach. Did I do the aces right? I did. The problem's on the screen, but that's the website I'm using to see what an orthogonal Latin square is. They have a few examples on there. It's a little bit hard to explain, but like, if you have 2 Latin squares are orthogonal, if you can look at every corresponding position and get every possible ordered pair. So in the 1-1, we get like ace comma ace. From that ace and that king, we get ace and king. And we go on like that until we get every possible pair. This one isn't right, though, because I have king, king, and I repeated king, king. So I need to... I didn't have any choices, though, is the weird part. Like, if this... I never made an arbitrary choice. I don't think. Maybe it's the first row that's off. Should the first... Maybe the first row was my arbitrary choice, and that's not good. Okay, so this ordering for the first row maybe doesn't work. I'm going to try a different ordering. Let's try switching the king and the queen. Okay. Did I make an arbitrary choice at first, maybe? Was that king there arbitrary? I think it was. Maybe that's the issue. Yeah, maybe let's make the other choice then. Because that could be a queen. I made two? Okay, I don't remember where the other one was. It was probably the next one I did now. If I make this a queen, then this ace should have to pair with the king, and then that ace should have to be a jack. Oh, okay. Yeah, fair, fair. Okay, now let's think about the kings. Uh, that king can't match with queen. We don't need ace, so this should be a jack. This king... Hey, Dora. Thanks for the lurk. We still need to match it with queen. We still need to match it... Wait. We have king, king. We have king, jack. So we still need... Wait, we still need ace. We still need queen. So we can put an A there. Oh, wait, but now we can't put a Q. Yeah, yeah, okay. So is queen there also wrong? I guess. So maybe my first verb doesn't need to be changed. Yeah, this is kind of tedious. uh we switch the queen and the king. Does this work now? This ace, it can be a king or a queen. Let's just choose king. This ace can be queen or jack, which really we can have either. Well, this ace can't be the queen. So jack there, queen there. Okay, all our aces are taken care of. King. We start with king and queen. Good. This king needs a king, but we can't have it there. Oh no, we can't do king king now. Dude. There's a lot of choices here. Like, how are you supposed to do this? We have king, queen taken care of. We need king, king, so maybe let's just take care of it with that. Course in combinatorics? No, I don't. I normally avoid combinatorics like it's the plague. We have king, queen, we have king, king. We need king, jack, and king, ace. Which we can't do. Okay, I'm cheating. Not that. Wait, so you can't have the first two rows the same? Ace, king, queen, jack. Jack would go here. Wait, so what goes? Ace goes there. What? Oh, do they not have to be unique? Or wait, no. No, I don't have the same starting square. That's the issue. That's so annoying. You can I have some of the rows swapped here. So I wanted to cheat, but I actually kind of can't with unless I start with a different square, I guess. Can we see a pattern in this? Like, is it just swapping rows? It is the same row, it's just swapped. This row is down there. This row is up here. That row is up there. Can we do the same swapping? Put that row down there. King, queen, jack, ace. These two rows get shifted up by one. Queen, jack, ace, king, jack, ace, king, queen. Oh, sorry, Jed, I didn't see that. Good night. All right. Good night, Storm. Sleep well. Well, now we have an issue here. We don't have ace jack. I know the left square is different. I was hoping we just copy the row operations they were doing. But we could keep... There's only 3 different combinations of row swaps to try. If it is just row swaps, that's not as bad to check. What? Not that. Like, does this work now? No, it doesn't. Oh my god. This might... No, it's not. Yeah, we're just gonna do this. I know it doesn't match. I was trying to make my original one work. I didn't want to do the exact thing that I'm doing now, which is just making my square. I wanted to make the square that I had work, but I don't know. I can't figure out how. Keep doing that. Allegedly, these should work. Ace, 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 king, ace, queen, ace, jack. Good. King, 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 ace, king, jack, king, queen. Good. Queen, 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 jack, queen, ace, queen, king. Good. Jack, 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 queen, jack, king, jack, ace. Okay, so yeah, these do work. I was trying to figure out how you're supposed to engineer this so I could tell it, I could explain it to that person, but I apparently just can't figure out how to engineer it. Oh, cool, you're still here, Louis or Lewis. I'm sorry, I'm not explaining this very well. What is it supposed to be? Greco-Latin squares? Okay, sure. I guess it's just more examples. What was your other question? No orthogonal pairs exist for order 6? I can definitely believe that there's random stuff like that that happens. That is super weird though. For which values of I and j can the following Latin rectangles with entries in 1, 2, 3, 4, 5, 6 be extended to 6 by 6 Latin squares? Oh, so these are 4 by 4 Latin squares, but we have 6 possible elements. Interesting. Hey, Batter. Thanks for the reminder on that. Let me. I want to have a not as much empty space on that. I'm just going to take a little screenshot of that and put it back up on there. An insane argument for an insane integral formula. After I do this question, I can think about it. Can I give your mom a shout out? Shout out to Lewis's mom. um, this one sounds like kind of a big question. I don't know if I'm going to do every single case here, but let's see if we can figure out what the idea is. Um, so for I, the possible choices are 3, 5, and 6. And so what could possibly go wrong? We choose 3 to start with. Um, let's just do a 5 and a 6 there for fun. A 3 and a 4 here, because why not? Two and 6 are the choices here, so 6 and 2 go there. Oh, okay, so here's an issue. Uh, we need to put a 6 in one of these two spots, but we've had to use up sixes already in those two columns. So I think 3 is a no-go because of that. I don't think we can get around that issue. So I say 3 is probably out. How about 5? What goes wrong here, if anything? 5, 6, 3, 4, 6, 2. Now we need a no. We need another 6 now. Okay, yeah. I think we have to choose 6 here because of the exact same argument. Like we have to have sixes somewhere here and here. So we have to we have to have a 6 here to make this work. I shouldn't keep erasing these examples because now once we do have a 6 here, we do need the example, right? You're zooming ahead and saying j equals 2. Let's see if we get this the same answer once I get there. 6, 2, 3 and 5. Oh well, god damn it. How does this work? I guess we can switch to 3 and 4. 3 and 5, and then switch to 3 and 4. Okay. Now we need 2 more rows down here. And we've got a square in our hands. 2 and 6. Let's just choose something. 3 and 5. Just choose something. 4 and 6. That's forced. 3 and 5. I guess we switch. 1 and 2. Forced. 1 and 4. Hey, okay. I got lucky and made the right guesses there. Okay, now what options do we have for J? A 2, a 5, a 6. You need J to be a 6 to have a chance also. There's only one 6 in the 4x4. We can otherwise place the remaining 5 6s among the last 2 rows and columns. There is only one 6 in the original. And the same is true for the first question. Oh wait, no, sorry, this can't be 6. J can't be 6 because the 6 is there. Uh, the row demands a 2, 5, or a 6. The column demands a 2, 3, or a 5. I think 2 and 5 then. And we were saying it's impossible. Um, what's the 2 situation looking like? So we only have two 2's in the original square. That means we need to place another 5 2's, as Lubert said. Um, I need to see it. I don't know. I'm having a hard time visualizing this. If we choose a 2, last 2 rows you can fit in 2 6's, and last 2 columns you can fit in 2 more 6's. That only brings you to 5 6's. Oh, right. So yeah, we don't think about the 2's, we think about the 6's. You're right. There's only a single 6 in here. Oh, right. So we would need... okay, so yeah, we think about we're extending 2 more rows down, but all 3 of these columns need a 6. There's no way, even in just the smaller situation, that we can get all the 6's here. Like, we need 3 6's in this area, but we only have 2 rows to do it. So that's why it's not possible. Interesting. Okay, cool. Yeah, I like that. So I hope that helps, Lewis. I'm just gonna assume that it's Lewis and not Louis, but yeah, I think that's how you would think about that. I don't know how to say your name. Oh, I mean, I said batter, but before, but that's my best guess for how you say it. Okay. Um, so syntax, do you want to put your crazy integral thing if you're still here? Yeah, sure, sure. You conjecture that the integral of the absolute value of f of x Do we have, is this for a particular f of x? I don't see where it's defined. Oh, it's right here. I'm just dumb. It's a parabola. Okay. Oh, for any f of x, and that's just an example. The integral of the absolute value of f of x is equal to the limit as z goes to infinity of pi over 2z. It's the integral. What? No worries, Lewis. I have no idea what that question means. Raise z to show convergent behavior. Although going above 60-ish breaks it, but I blame Desmos. What kind of like fucked up transform is this? You use another graphing calculator, got results for larger z. Came to you right before you fell asleep yesterday. Were your dreams haunted with nightmares? um, the Discord link? Oh, I'm sorry. They're just weird sometimes. I don't know why. I would need to make z go to infinity for it to. Oh, okay, yeah. That is getting close. I want to mess with this. So I feel like I can make it look a hell of a lot like this just with algebraic manipulation. You have a geometric interpretation for this. Okay. I am interested. Because this reminds me, I feel like you made a custom Laplace transform or something. Is what this kind of comes down to. But even then, maybe it's not even that fancy. I don't know. If we actually took the derivative of this, it would be 2 sine zx f of x. Now, the chain rule gives us a product rule. Z cosine zx f of x plus sine zx f prime x dx. The squaring is outside the derivative? Oh, you're right. Hey, Ninja. Yeah, what I'm trying to prove is that you really is that you more or less, or what I'm trying to investigate at least, is that you basically just taken this thing and multiplied it by a fancy version of one, as far as I can tell. Hey, Odin stream. You can put it there in chat, or it's easier to put a screenshot. You can post it in my Discord. Hey, Ninja. I said in distance file, and the ladder is in the form of arc length. Yeah, it looks a lot like an arc length. Um, and so in the limit, this thing zeroes out. Uh, we can square root this and bring it inside the parentheses. To z. Oh no. Never mind. This isn't working out how I thought it would. Um, my point was going to be that in the limit, this term becomes 1. I believe then that's not quite right, though, is it? Well, I mean, that is right, but it wasn't going to get me where I thought it would. No, yeah, okay. Maybe my thing isn't right. So I'm not getting anything that actually means something as far as I can tell. Raise Z to show convergent behavior. JA exam was hard in the SAT. No worries, Ninja. The JE looks super hard, so good luck with it. Taking it to today? Oh my god. Good luck, Ninja. Godspeed. Wait, show which G of X syntax? Like, oh, I see, like, show it like that. Oh my god. What? Did I say hi, Hamish? I don't know. Either way, coffee is life. Odin stream. It's a bit of an open-ended question. I wonder if there's a way to reverse engineer x equals 0 to 1 functions? I'm not a math head, so I'm not sure the official name would be. Like, if I gave you a tone curve, would you know how to reverse engineer that by looking at it? Like if you're just given the graph of something, I guess. Uh, if you know the graph, or there's a thing called interpolation, where if you have data points that you know fit a type of curve exactly, as long as you have enough data points, how many you need depends on the type of curve you're trying to fit. As long as you have enough data points, you can reverse engineer what that function is. If they don't perfectly fit a curve, you need to do something called regression, where you find the closest curve that, or like the curve with like the minimum amount of error. I'm not sure if that's what you're talking about, but there definitely is a process to go from data to a general function. And depending, if it's like real world data, you're going to do regression. If you have something that's like, because real world data has noise, it's not always like perfect. Um, but if you somehow magically have points that do fit onto a curve, um, you could do interpolation. But it kind of like I might need to see an example of what you mean, to be honest. Okay, so let me catch up with what syntax is saying. The idea is that as you increase z, the period where that goes from equaling f of x to minus f of x gets shorter. Increase z, the period that goes from equaling f of x to minus f of x gets shorter. I agree the period is getting shorter for higher z. I don't know how that. This is weird. This is an insane formula. We know the length of that period. And as that gets shorter, these waves get close to being straighter lines. They would start resembling rectangles. I guess so. Oh yeah, Papador, I'm sorry, I read that, but then I got distracted. Desmos at some point a while ago did a big update. They could do integrals, derivatives, limits, complex numbers. It was updated maybe like a few months ago. If you view this in the range of 0 to 1, Yeah, but why is the arc length equal to the area under the curve? Like the arc length of the rectangles isn't their area. It's why your math teachers really don't like you. Sorry, I'm trying to think about two things at once right now with this. So I want to also think about what Odin is asking about. You're talking about just about in the range of 0 to 1. Like the x values between 0 and 1, or c values? Just the xy. Okay. You don't know where to start with getting it closer. Um, so yeah, if you have a curve you're trying to match, you would basically ideally write a program that'll do like 100 test points or something. Like you would try to fit a variety of functions to the thing that you actually have and figure out which one is either the best fit or a perfect fit, I guess, is the process that I'm thinking of. Um, that's why we multiply the length of the period being the width, arc length being more or less height. Oh, I think I see what you're saying, syntax. Oh, that's so messed up. The higher z is, the taller these things get, the closer they get to vertical lines. And we're getting the arc length of those vertical lines, which is basically the height of a rectangle. All right, see you, Ninja. Good luck. Um, and Papadori, this question is just from syntax error in the Twitch chat. Syntax error tends to cook a lot in math and make crazy formulas like this that seem okay to me, to be honest. Um, and this is the width of, wow. I don't know how to begin poking a hole in this, to be honest, but it seems like not bad. The function you're trying to replicate has more literality. In the middle and toe and shoulder are more linear in this math I have. They're more linear. Um, yeah, 'cause I kind of know like Odin, I kind of like the like general techniques for like if you have data to fit it onto a curve. I feel like are you coming from maybe like this maybe like a circuit or audio or something like that? Like it depending on the it's for shader math. Okay. Because oftentimes the place that you're trying to apply it to can give you some sort of intuition for what the function should be for image processing. Okay. but it's a good curve. Yeah, it's a nice curve. So they increase or decrease the contrast. Interesting. Um, hmm. As far as I know, it basically does come down to guess and check with every function you can think of, or every function that might work that you can think of. That's kind of the unfortunate thing. It's possible. Uh, hmm, sends an image in Discord. Okay. Uh, wait. Yes. Syntax for your thing. Does it resemble a Lebesgue integral? I don't imagine it does. I don't know them well enough though. That might be a better question for Zach. Um, this is just something strange. I would think if this is more like a transformation of some kind. That's what it reminds me of, at least. Um, I don't know how you prove it, to be honest. This is just really cooked. That's the curve you want to reverse engineer. Algebra came to you at 3 a.m. See how it preserves linearity at the points. I guess so, yeah. I'm trying to figure out if we can make a Taylor series with this somehow. Can we numerically get the derivatives? You couldn't sleep until you wrote it down. Oh my god. It's a really interesting question. It reminds me a little bit of like some version of the cube root of x. but it's not quite that. And of course, we need to like translate it a bit, but not like that. Like it's possible there's some a gamma function. Okay. And syntax, I think that's I don't even know like what to say about it. Sorry, I'm trying to think about both things at once right now, but like I really don't know what you do with this crazy thing. Because like in math, when I hear gamma function, I think of a different thing. But I guess yeah, I could see how gamma for a different or like gamma also has a meaning in image processing. Um, let me what I even I really like this question. I'm sure that someone has done this at some point. I'm just trying to figure out what you would like search for to find this. Like, I guess that is it should be called curve fitting. Like, I feel like there should be a way to uh use polynomials here. It might be a really big polynomial. Oh, it'd be hard to make it match the boundary cases or like the boundary conditions. Hmm. Maybe this is something that you would want to use software to try a bunch of curves for you. Because the thing that I was thinking before is trying to numerically calculate a Taylor series, I don't think is a very good idea. Um, Damn, yeah, I'm sorry. Offhand, I can't like I don't know of a good technique to do this from. I feel like either specific in the image kind of processing world, someone has thought about this before and has come up with a function that this type of thing would fit to. But absent that or being able to find it, it might be worth looking into some type of like package that can do curve fitting, like software package. I mean, technically Excel can do it too in some basic thing. Add more straightness to the curve on those specified points. Uh, yeah, I'm not quite sure what that word would be. I see what you mean, where like it's pretty linear there and there and there. Um, and how you? I mean, we'd have to like you could try adding a bunch of parameters in random places and seeing what effect they have. And the thing is, like that could obviously be really tricky. Like it could even like it could even be like a combination of parameters, and that'd be really hard to find with just playing around in Desmos. It kind of like I imagine it would depend on the function what you would want to place where to affect the shape like that. Hmm. You lower the contrast, it reduces the slope. So my assumption is that the math is different for minus values and plus values. This makes me want to like take x and divide it by something. Like we want it to be to pass through the point 0, 0, and 0 and 1, 1. We want a function that's going to kind of decrease it between 0 and 1 half, and a function that's going to increase it by the same factor between a half and 1. And surely there's a function out there that can do that. For reason like sine is coming to mind. I don't really know why though. You know, actually, I guess we want the function to be approximately 1, around 0 and 1. So maybe cosine pi x over 2. You've got the slope with this. Oh, the slope like in the middle there? Oh yeah, true. The slope in the middle wouldn't be 1, would it? And I guess if we were to assume this thing is symmetric, we could worry just about the upper half and reflect it down for the lower half. For negative values of C? Or like negative X values? Negative. Oh, I thought we were only going between 0 and 1. For negative things for contrast. Sorry, I think I'm not interpreting you right. That matches the second image you sent. And you reduce the contrast. Okay. Yeah, I'm not sure how this function you just pasted into the chat is related. Or like, I assume this value of C that gives you that slope. Hey, Monsieur Kun? You're a Koch. Oh, nice. Yeah, I remember you. Okay. Um, what's like the end goal here? Um, like, are you trying to get values between data points, or are you trying to? Well, yeah, but like, what are you going to use that curve for once you replicate it? Like, there might just be an easier way to do this. I guess like how are you getting this curve then? Like if a program is producing this, wouldn't the documentation say what algorithm whatever this is coming from? Like that might be a better place to look than trying to figure this out from scratch. Um, yeah, like I, I think the best like you would get the most mileage from trying to search for like whatever algorithm this is based on or like whatever's actually like doing this because it's really difficult to just do this from scratch. It could be a bunch of different things. I was like, like there's infinitely many functions that will look kind of like this. If you want to do it very generally, you could get data points from this curve and feed those points into some software like that does curve fitting. That's basically just guessing and checking though. um, yeah, I wish I just had more experience with how image processing is done because I imagine there's some clue in the context that would tell us like how the hell something like this would work. I don't know enough about it for myself. Yeah, so the question is basically if you're given a curve that looks like this, how can you find a function that fits it? In Kun, uh, I'm not a student right now. I just enjoy tutoring. Yeah, this is something that'll be like cool to learn more about for sure. Um, but I feel like the general answer for how do you fit a curve to data would probably work here, but maybe not be as insightful as trying to figure it out in the context this comes from. So yeah, I'm sorry. I don't know. I wish I could get you a more satisfying answer, or that I could just figure it out. Um, it's kind of difficult though. It's like one of those just curves you see often. Yeah, I mean, if you have an idea for how it could look, please do. Like, I guess some of the important features are like it looks approximately linear at either end and in the middle there. And this function here was kind of something that Odin gave, something that's kind of like it, but it's a little too curvy. It's not linear enough in the right places. Like, it's logistic. That's not like a log. Is that logistic function? Can you be more specific, Jasu? Because I. Oh yeah, it does cut. It does kind of look like one. I mean, I guess it is just kind of a sigmoid. In the I guess you could name a lot of functions that look like this. This does seem to be more linear, though. Yeah, my mind went to logarithmic, which wouldn't be terribly related. What are you saying, Batter? Logarithmic encoding and image processing too? Oh, okay. LCM question might be evil. Sure. I think I want to switch gears soon anyway. What the hell, Desmos? Yeah, so why does Desmos messing with me like this? I don't know. I mean, you can mess around with the logistic curve too, but I don't know if that's really the thing that you. I mean, that's actually not looking bad at all. Is this just the answer? Like, or is it maybe it's close enough? Close enough isn't good enough. That's the issue with curve fitting, though. It's always like if it's real data, there isn't going to be a perfect curve. You can only ever get close enough. Has to be able to be scaled from linear to curve. Because linear is no change. Um. Hmm. So what c equals 0 does here? Oh, interesting. Okay. Yeah, that makes a bit more sense now with the different values of c. Yeah, so I yeah, I wish I had more that I could say about this, but it's an interesting question. I'm just not sure that I can really help though, unfortunately. Do I know someone who can? I don't really know. This might be a little bit too niche. I don't think I know anyone who knows specifically about like image processing like this. But thank you for trying with me at least. Or maybe Jasu saw some thoughts. I think I'm going to take a look at Papadori's question. And even someone might get back to you in the Discord. Let me actually write a little note, and then I want to look at Papadoria's question. Hey, Fembox. You're here just in time for a Papadoria question. I'll write a little note in Discord with what we talked about here, and it's always possible someone will get back to you. It's not guaranteed, but maybe someone will see and be like, "Oh, I know about that." $10 just dropped in. Yeah, you're looking and you heard the name. Oh, nice. Before I read this, though, I'm gonna write the note in Discord about Odin's question. Yeah, I was trying to think about like polynomials and numerically calculating derivatives to make a Taylor series. It just felt like there was an issue with it to me for some reason. I'm almost there. An example of a function that almost works, but not quite, is a little too curvy. Where the function looks about linear around x equals 0, 1, and or x equals 0, 1/2, and 1. Okay. Sorry, I just wrote a little note in Discord, and then we're gonna think about Papadoria's question. Just got to get into the English math terms. Oh, like we're talking about math and English. Um, okay, so they're asking us to find the size of the set A. And A is the set of all positive integers less than or equal to 1,000. So 1, 2, 3, 4, 5, all the way up to 1,000. Except only those that have a least common multiple with 9 as a perfect square? So a least common multiple is the smallest number that they both divide. So the least common multiple of like 5 and 15 is 30. Because oh no, I'm sorry, it's 15. Nope, that's a bad example. Oh my god, dude. I mean, that's still not a bad example, but I should choose a different number. The least common multiple, like yeah, of like 5 and 7 is 35. I was trying to give a different example. If you were to do it with 5 and 15, the answer would just be 15. Because 15 goes into 15 and 5 goes into 15. Maybe 12 and 8 is a better one. The least common multiple of these is 24. So it's not always multiplying them by each other. Oh yeah, and Papadoria. That's a good one too, with 6 and 8. So like some CDFs you've seen. Cumulative density function? Like with probability? 6 and 9? That's gonna be 18. Oh, you're just making a dumb joke. Okay. um so how many, and so essentially find how many n's less than 10 cubed, or LCM n9 is equal to m squared, or m is a natural number. Yeah. So we could write the LCM as kn plus 9l is equal to some m squared. I don't know if this is helpful. Instead of 9, replace with g. Oh my god. Bruh. It's Don does math. Z. It's Gin Reaper. Z. Or no, Jin Reaper? I always think Gin, but it might be Jin, I forget. That's why I just call you Reaper. Hope you're doing well, dude. I'm not sure if Odin's still around. They are in the Discord though, in math discussion. If they don't get back to you here. Jin, okay. It's like GIF and GIF. The gym button? I don't know what that is. I think I need to manually calculate some values here. So I don't know. I don't know where else I'll start here. So 1 should work. 3 should. Oh wait, no, does 2 work? No. Stanley Parable. Oh, okay. I've heard of it. I never played it. Does 4 work? 36? Oh man, that's terrible. Why does 36 work? Or 4 work? A perfect square is like 4 is a perfect square because you can write it as 2 squared. 9 is perfect square because it's 3 squared. 16 is 4 squared. So these are all perfect squares. Basically, yeah. Like 5 isn't a perfect square because the root of 5 is some weird irrational number. Or you don't call it imperfect square, you just call it not perfect square. How about 5? 5 doesn't work. Does 6 work? 18. No. Oh, Slim. Thanks so much for the raid. Well, welcome in, everyone. Yeah, Lucas, like what you said there. I hope your stream was good. I was working on this question from Papadoria in the YouTube chat, and Papadoria is infamous for giving very difficult questions. I was trying to figure out manually a couple of numbers that work for A here. Ooh, Mert. That's a great thing to think about. The LCM of AB is equal to A times B over the GCD. It's an infamous description. 3 is not a perfect square, Lucas. The point of the question is that A is a set of, like, 3 is here because the LCM of 3 and 9 is equal to 9, and 9 is a perfect square. So because the LCM is a perfect square, we include the 3. That's what the set A is. It's square root 3. 31 plus 21 plus 10 plus 4 plus 8 plus 2 plus 1, you've overcounted. The LCM is equal to A times B over the GCD. Since D is equal to 1, 3, or 9, Bluebird is guessing 49. Question a little too weird for you? No worries, Lucas. So yeah, the GCD on the bottom has to be 1, 3, or 9, as Mert says. How do we know when this is a perfect square, though? Find exclamation point equal to 1. Okay, string shorts, you need to run some errands. Oh, okay. Factorization of n and prime numbers. See that each prime must be a square. Except for possibly 3. That can appear as just 3. Each prime must give us a square. Really? Five doesn't. Group theory? No. When Penn Center was doing an abstract algebra reading group, I read along with it for the first like 6 chapters of a book, so I know the bare basics of group theory. That's about the extent of my experience, though. Yes, I hope your errands go well. Thanks again for the raid. Um, no quite much background as analysis. From what I've studied, but algebra is kind of boring to me, to be honest. What is the LCM of n, comma 3 squared, and you write n as prime factorization? No, this is not algebra. This is like number theory. The LCM of AB is all parts that appear in both A and B to the largest power they appear. Oh, that's basically another way of saying this. The LCM, right? I remember I've done this before actually in studying for the abstract algebra. 3, 5, 11. It's 3 squared times 5 times 7 times 11. 5 cubed. Since b equals 3 squared, you know all prime numbers in n must appear as squares, except for maybe an extra 3. All prime numbers in n must appear as squares. In order for this thing to work, yeah. Well, I guess squares or even powers. Like, I guess we could write a general form for n. N is equal to 2 to some even power times 3 to some... Well, the 3 might be a little bit finicky. But 3 to some... Like, it should be written as, be able to be written as prime numbers to some even power. 3 is a little bit tricky. But those are the ends that would work. Once I revise my 3 in some way. Name all perfect squares under 1,000 and check which are divisible by 9. Yeah, thank you for the thoughts, son. Hey, good computer guy. How's it going? Good to see you. Um, I think that would work, Lucas. But Papadoria is gonna have to like the part two to this problem is that instead of nine, you just have a generic number G, or that's not going to work as well. So it'd be better to figure out a good way of doing this. Testing new computers, living the dream. Okay, nice. Now this is calling 52. It's not far from Lubert's 49. I'm doing well, just staring down the barrel of a Papadoria question. Wait, we've had some good like starts here, but I'm not sure. Maybe I don't know what you're talking about though, Lucas. Hey, Destin, do you know about like the simple group Discord? I don't know that much about how it works, but I know they have a lot of like reading groups. They did have one in abstract algebra that ended a little while ago, but like they tend to just start up studying groups on a bunch of different topics. I think right now it's like topology. You don't think you got it? Oh, okay. Yeah, like if you're like, I don't know very much about it for myself, but like if you were to like just ask like asking the elements Discord or like ask Penn Center, I'm sure I'd be happy to like if there's something happening, he'd probably know about it. Operator theory? Oh, okay. Hmm. This approach with thinking about the prime numbers, I think it's going to get out of hand very quickly because we'd have to know every prime up to 1,000, right? Theoretically, you're going with 43. I haven't gotten a single answer, so that's more progress than me. So Ranger likes 43. 57, it's the Grothendieck prime, right? It's 3 times 19. I only know that one because I remember hearing Stookie tell the story. of that number. 31 is the number of squares up to 1,000. There are 12 more that are both relatively prime to 3 and less than 333. "31 is a number of squares up to 1,000. Can all of those be written as the LCM of 9 and another number? Surely not. Like 25 is a perfect square, but you can never capture it with this, right? The LCM of 9 and x squared is a square. Oh, I'm thinking about it in reverse. Oh, fair. And this is what this is what like Slim was saying. That's the way of thinking about it. Hmm. Um. 31 is a number of squares up to 1,000. Then there are 12 more that are both relatively prime to 3. Let me just... get this on screen, so I'm trying to like think about it. Yeah, she wrote a list of all squares under 1,000. Oh, geez. Largest one is 31. Yeah, I guess you'd have to just figure that out by hand, Lucas. Is 1 a perfect square? I guess so, yeah. I think it is. Oh, I meant to copy this piece in. Like, so for this rationale in the first sentence, you would need to manually check 1 and 4, right? When it's greater than 9, I can just buy it because of the argument we said before. Actually, no, it's fine. Never mind. You don't need to manually check those. Oh, yeah, it probably is the other way around. Um, okay. I agree with the first sentence now. I think I understand what it's saying. Or the first, not in the first sentence, the first part. "12 more that are both relatively prime to 3 and less than 333. And these numbers are not perfect squares. They are 3 times a perfect square. And the perfect squares have to be less than 333 because we're multiplying it by 3. So you're basically taking the list of perfect squares and multiplying these all through by 3, as long as they don't already include 3 inside of them. Or like as long as we haven't already counted them. Which I guess is really just 9, right? So this formula is basically number of perfect squares less than 1,000 plus number of perfect squares less than 333 minus 1 to get rid of the 9 that we'd be double counting. Is that basically what the 43 is? Or I guess we are double counting things, but we're supposed to double count things except for 9. Right? So perfect squares in the roots. Yeah, there's a thing where perfect squares are equal to the sum of something, or I forget exactly what is. Because my brain is slowly crashing here. When we open all the cases, as I said before, we'll have the same thing, but different values. 9t, for example, if d equals 1, LCM x squared equal to n 9 over 1. Yeah, what you're saying probably works. I'm just losing brain power. So I need someone to just write out the argument for me at this point. I think like so you can do a sigma. Yeah, 1 plus 1 plus 1 for each one. It's linear and exponential. I'm really not sure what you're saying there, Lucas. Um, I think there's a thing where if you It's like the sum of odd numbers gives you perfect squares or something like that. It should be divided by 3. Oh, or I guess like you can instead do like times two thirds, like that. The third square is a triple. Those have to be ruled out. Or maybe wait, no. No, redo. That's times two thirds or whatever. D equals 3, n equals 3t. Okay, Mert. Do for the first 5 numbers, their squares are difference 4 minus 1 is 3. No, it's not. I'm not actually doing 33 times two thirds. I'm writing in words like where this formula like comes from. Do you have the actual what the answer should be for this Papadoria? The next one is going to be replacing 9 with a generic number g. Uh, I don't know how you would count the relatively prime piece, I guess. Papadoria might have stepped out or something. You want to play this, but also not. um, so wait, looks like you're talking about the spacing of perfect squares, right? Like that's 3, that's 5, that's 7, and so on. Like it keeps going by odd numbers. Or are you trying to do the original problem? Because at least for this, you don't know what you're trying to do? Okay. Well, since you're getting into it anyway, if you were to think of this progression as like n squared, the fact that these scale linearly, they go up by they go up by 2 each time, isn't a coincidence. The derivative of n squared is 2n. So if you have a quadratic progression, the distance between any 2 points is going to increase linearly because the derivative of n squared is 2n. It's a little like connection, I guess. It's a little bit weird because derivatives are continuous and we're talking about discrete things, which is maybe those aren't good terms to use when you're not studying math and English, but it doesn't make sense to go halfway between 1 and 4 is the issue, and derivatives would do that. So it's not a perfect like metaphor, but that's basically like it's a similar idea. Okay, yeah, I think Popularity might have stepped out or isn't here anymore. Um, I don't really have anything to say about this question, to be honest. I just don't really get it. I sort of get where things are coming from, but for the reason that I'm just it's not really connecting for me. Um, you checked it with Code Mert? Okay, so at least Mert from the YouTube chat has gotten 43 as well using code. I think it's the closest thing to confirmation that we'll get. How n times n plus 1 over 2 is the sum of perfect squares? Um, isn't that the sum of just numbers? Yeah, so go away. All right, CFM Lux for now. The formula that you put is summing just integers. If you're summing squares, you get this formula instead. And I know how to prove these by induction. There's probably a more intuitive way. Ooh. This is just for integers. What's happening here, though? Or, like, not for perfect squares. Just for regular numbers. Hmm. Wait, what? Gauss sure was something. Fallhaber's formula? Yeah, I've seen it. It looks kind of crazy. Yes, just put a question in the YouTube chat. The mall, what? They're all to the power of 6 when he was a kid? I don't know what that means. Let's think about Yash's problem. So we're minimizing with a constraint. I think wouldn't we just like we could take the thing that we're given that we have to optimize and we can make it a one variable function, right? Because if 1 over x plus 1 over y equals 1, we could solve this. Let's just solve it for y, I guess. Y should equal... What does that equal? 1 over 1 minus x. Oops. 1 minus 1 over x. And we can multiply that by x over x to get x over x minus 1. Did I do that right? I think I did. And so we could take that relation and plug it in. Oh, well, that's annoying, but we could take the derivative of that, set it equal to 0. Oh, he found that without searching it up. That's kind of crazy. There is a formula out there for any power, but it's kind of crazy. We could do this the multivariable way also, right? That'd be like a Lagrange multiplier thing. This derivative just looks kind of incredibly annoying. How does... I need Paul to remember how this works. Times... What am I multiplying 64 to the y over y by? Del f equals lambda del g. I don't know if this is going to be easier or harder. We still have a lot of derivatives to find. I don't want to make them the same fraction. I think it's going to make it harder. What an annoying function to have to optimize. I think the Lagrange multiplier is honestly easier than taking that derivative, though, in one variable. Okay, so... Yeah. So if we're going to let f of x, y be the thing we want to optimize, we need to find the gradient. So the x component is the partial with respect to x of this thing. This thing with y's goes away entirely. Lucas, I'm sorry, but I don't understand what you're suggesting. Um, the derivative of 31 to the x is 31 to the x ln 31 times 1 over x. And then proportion respect to y. Oh no, I'm sorry. That I was doing product rule and then I stopped doing product rule. Minus 31 to the x times 1 over x squared. Go through programming marathon, want to finish up to your textbook? Oh, nice. Godspeed to you. And then the partial respect to y, well, the same thing, but with 64 and y's. You, Lucas, that's allowed, yes. I think it's making the problem harder, though. um, and so G is just that thing. And we need to find del G. Um, minus 1 over x squared, minus 1 over y squared. Okay, so... Oh god, this is terrible. We're taking this thing, setting it equal to lambda times that thing. Minus lambda over x squared. Well, this is just one variable. Okay. God help us isolate x, but bring it there. Lucas, this problem up here, I'm doing things that are, it's like a multivariable calculus thing. um, the issue with this is that it kind of sucks. We like we can't isolate x or y here. Um, we can isolate lambda, but we like we want to solve for lambda. I mean, I guess we really just need the x's and the y's. I mean, global subject to the constraint, I think. Next problem is from your math test. Given the minimum value is 2015, we have to prove the statement is correct or not. Oh my god. The fact that that's a year makes me think this is like a competition problem. I don't like how are you supposed to get an x and y out of this? um that's not how the derivative looks, Lucas. When there's multiple variables involved, things get weird. It's not as simple as that. Hmm. Like I don't see how this is possible to solve by hand. It's a 1 mark problem. You're able to solve the much harder ones. This one just sucks. It like I there must be a trick that I don't see. Non-wizard too. Thank you for the follow. I'm trying to like find tricks. Like this is nearly like a 1 over x plus 1 over y. But I guess those exponentials are in the way. And just seeing how the Lagrange multiplier way works out, I honestly think the single, like, plugging this in for y and doing it as a single derivative is probably more likely to work, but still be really painful. These are all the partials here, Jasu. Like these are the gradients. The first one is the partial with x. Second one is partial with y. You can't solve it by like the issue is that we have like exponentials and things that aren't exponentials. Like we just can't solve it by hand. Oh, a change of variables color code? All right. Let's look into that. Oh, hey, Papadoria. I other people were able to answer your question. I still don't quite understand it, but this is like what Fenblock said. And the answer should be 43. We had multiple people agree on that. Um, to be honest, my brain is a little bit too fried right now to understand why, but it like I would like to take a look at that for an explanation of how to think about it, and if you don't mind, like taking a screenshot of it or something, so I can scroll back down. None of this ended up helping. Well, yeah. No. I don't know how like I still don't understand how to do part A, to be honest. So I didn't try with part B. And I already spent a long time just staring at it, getting nothing done. So I moved on. If you can solve those to be equal to zero, I mean, even then, just that's just for general optimization. Um, if you have a constraint, it's not necessarily just where there's zero. And it'll be you just can't make it equal to zero by hand, or you won't be able to solve it by hand. You have to get a numerical answer. It's an interesting change of variables. I guess you would know that's true for all t. What would this do for us in the function? Are we taking the derivative of this and setting equal to 0 though? Because I don't want to do that. It's not going to be this one. It won't be solvable by hand either. Yash tried the substitution and it didn't work. Yeah, sure it's one variable. I can't imagine this is a helpful way of making it one variable though. Um, yeah, I just don't know how I don't know, man. Like this is when you just need to do it numerically. To be honest, there must be some weird trick if you're being asked this question. I just don't see it though. Um, yeah, I know. I'm sorry, Yash. I don't know. I don't know how to do this. Um, I mean, why would that be true though, Finbox? Are you going back to like the Lagrange multiplier thing? Oh, thank you, Yash. We can take the derivative probability. It's just a nightmare and not really solvable by hand is the issue. And so I dual stream to Twitch and YouTube. On YouTube, there's not that many people who do this, but there's at least Actual Education, aka Dr. Gold. Is this command going to work? Hey, it works. Okay. So if you're interested in this like type of stream, he's another person who does that on YouTube. I've gotten a feeling with these problems that all the time once you work out what the variables are to optimize the function. Yeah, that's the thing that I keep running into. Like the one variable derivative is painful. If you try to do it the Lagrange multiplier way with multivariable, it's painful. Not just painful, but just impossible without numerical methods. Yeah, looks I had that at 1.2. That's the part where it gets very painful though. Yeah, this is what I got for Lagrange multipliers. Like from here to here is my work, and like this step here is where I got stuck. No, just put it in the YouTube chat. I can paste it there. If you want to like work on it offline. Uh, I just posted it in the Discord. Uh, Zone Ranger came up with a solution. So the actual value of the function is supposed to be 2015. Um, 31's the X. Well, yeah, let me what Hembox is saying. The constraint gives us that x plus y equals xy. Ln x plus y is equal to ln xy to ln x plus ln y. Sure. We're using multivariable functions because that's what someone asked. Um, You're off to bed, Chasu? Alright. Thanks for hanging out. Hope you sleep well. You get a minimum of 1984. That's what I was just typing in here. Oh, okay. That's true. The answer isn't 2015. The answer was, is it 2015? Yes or no? Um, I don't know how you would get that. Or I don't know how you get that. I don't know, like 31 to the x, 64 to the y over x times y. You could make this x plus y. No, I don't know that really helps. Because the problem is that that can't be solved for x, not by hand. You need a computer to approximate it. Okay, I have no idea how you would get the answers to this. It seems like Zone it's got an answer that seems reasonable, but unless you want to tell me that's like how you start with a zone. I'm probably just gonna wrap the stream up, to be honest. In Cockroach, I saw you put a different version of the idea in there too, but I have a hard time believing it would lead to anything nicer. Is there a version of logarithmic differentiation with gradient? That might be an angle to use Fenbox's idea with the LNs. I mean, that wouldn't actually change the value though, right? You'll probably still get something that's incredibly difficult to solve. Maybe you change it to one variable first. No, but then why would you change it to one variable if you're gonna... No. You can Cyto say you just get something that's terrible to take the derivative of and probably not possible to solve Like you can't, if you try to set it equal to 0 and solve, it won't be possible to do it by hand. You need to do it numerically. Okay, zone. You started with Lagrange multipliers. Y over y minus 1. I assume the ln is on top. Or on the side. I don't know where that's coming from, but oh, these two things are the same. Oh, okay. So you're setting basically this equal to this, and you're subbing the x for y over y minus 1 from the constraint. I thought that would be a dead end. I guess evidently it's not. Okay, let me see if I can. 31 to the y over y minus 1 minus y over y minus 1 times 31 to the y over y minus 1 ln 31 is equal to 64 to the y minus y 64 to the y ln 64. Okay. And so you're equating, you're basically saying that this piece of the equation has to be equal to this piece of the equation. And likewise with these two pieces is how you got the two separate equations. Mine looks slightly different. Well, no. Mine does look slightly different. Oh, because you factored it out. I see. You did. One minus y ln 64. Okay. Now I see where these two equations come from. Oh, this is possible to solve, isn't it? Wow, that is kind of mind-blowing. I was so sure this wouldn't be possible. Something like a times by equals cy times cy. You then show that ay times cy, or ay equals cy gives the same solution of by equals dy. So y must be the solution. Yeah, it does seem like these would be solved for the same value. And I guess the one on the right is, well, is it easier to work with though? I guess if we take the element of each side, we have basically the same thing. Okay. I don't know. I'm just kind of doing things now, but maybe they'll go somewhere. Yeah, I stopped too early, I guess. $64 times 31, presumably that's 1984. Yeah, it is. Okay. And the same thing as log base 64 of 1984. Wow. Holy crap, zone. Then I guess we go back to the constraint. To get the x. I mean, is there an easier way? Just the numerators came out to be equal? Yeah. The denominators are different. That looks really annoying. X is supposed to be log base 31 of the same thing. Is there a quicker way of getting it? No, I guess you have to just deal with this. Um, X equals Y. Oh, doing it like that. Okay, yeah. Thank you, Zone. Sorry, my um for a reason I'm just not with it today. Lucas with with that. I think you're still gonna get something that's not solvable for X with that. I want to figure this out though. Um, I guess you would simplify this by saying 1 is the same thing as log base 64 of 64. And that's how the 31 is going to pop out. I see. So that's going to be log base 64 of 31. So you can just do a change of base. Okay. Wow. Okay. I assume you're not still here, Yash? I don't have a way of contacting Yash either. Okay, I hope Yash checks the recording then. I'll type Yash's name in chat. Oh, you are here. Okay. Um so I don't know if you were watching for this, but the Lagrange multiplier way is actually not as bad as I thought. I I stopped after this step because I thought it'd be terrible. But if you take this and let x equal y over y minus 1 from the original constraint, you get something that's actually not that bad to solve. Um, it's a little weird, but it's not that bad. But uh, the y value where it happens is log base 64 of 1984. The x value is log base 31 of 1984. And the actual minimum value, when you plug it back into the function, those x and y, it should just be 1984. I was wondering why 31 and 64. Those seemed like very particular numbers. Um, it's a great method. Yeah. So really well done, Zone. Thank you for the help on that. Lucas, you're asking about this, and so just to be a little more specific. Oh, well, you could take the log of each side. Except you probably can't because you get ln of a negative number. So, unless x is something... No, you probably... Maybe for certain values of x, this is valid. If x is less than 1 or something. Um, let me... If you had a simpler case with like 2 to the x equals, I don't know, 5, you could, like, the property that you're probably asking about is, like, you could take the ln of each side. You probably want to take the log base 2, but just to show the property. If you have ln of something to a power, you can take the power and put it out front. X ln 2. But with the situation that you're in, it's a little bit weird because there's like a negative number there. Yeah, guys, my brain doesn't work. I need to wrap up the stream. We had a lot of problems today though. I didn't even get to actually like do any studying, so it's always a good sign when we have a lot of problems flowing in. So yeah, just as a warning to everyone, Saturday will be another stream, but it's going to be the first meeting for the reading group. So the first 2 hours are going to be about general relativity and not math help. And then after those first 2 hours, I'll do a normal like math stream. But yeah, it'll be streamed to both Twitch and YouTube. So yeah, I'm gonna cut the YouTube stream off here. So anyways, here on YouTube, thanks for being here. I'll be back on Saturday on YouTube for the reading group and then math. So yeah, bye YouTube.